As VP of Research at OpenAI, Jerry Tworek was a part of many of the biggest advances in AI these past years. Reasoning models like O1 and O3, Codex. He recently left OpenAI, citing that he wanted to pursue research areas that were harder to pursue within a big lab. I'm Jacob Efron, and today on Unsupervised Learning, I got to sit down with Jerry to talk about everything that's happening in AI right now and where the space is headed. We talked about reinforcement learning, what's required to further scale it up, and the origin of the ideas for O1 and O3. We talked about continual learning and other research approaches and how Jerry is thinking about their promise and the problems to go solve there. We talked about his reflections on 7 years at OpenAI and some of the key decisions that had to be made, as well as how he sees the race between the foundation models playing out from here. And we talked about what makes good researchers and ultimately why researchers choose to work at different labs. It's just a fascinating conversation to get to ask everything that's top of mind in the space today with someone who's been so close to building these models and is really zooming out to think about what's next. I think folks will really enjoy this conversation. Without further ado, here's Jerry. Well, Jerry, thanks so much for coming on. I've been super excited for this episode for a while. I feel like you've been behind some of the biggest breakthroughs in AI over the past years, O1, O3, Codex, and now have some really exciting next steps. I know you've left OpenAI to pursue something new. So I really can't think of a better person to talk about the state of where we are with AI today and kind of all the potential future directions.
Thank you very much. Very happy to be here. And AI is one of my favorite topics to talk about. So let's do that.
Amazing. Well, I think I'll start with, you obviously played a key part at OpenAI in introducing reasoning models and then scaling reinforcement learning. And so maybe we'll start with the existing scaling paradigms. And I'd love to get your temperature. How far do you think we have scaling the current vectors we have of pre-training and RL? Like, where does that get us from model capabilities?
No, it definitely gets us somewhere. The question is, how do we call that place? How do we name it?
I figure you could tell me.
But it is a very, very real, and for most practitioners, pretty striking thing that the benefits to scaling are real, predictable, and nice. And whenever we scale up pre-training, we get better pre-trained models, which fundamentally know more about the world, which fundamentally understand language better, and fundamentally build the linguistic world model of everything around them. And in the same way, scaling up reinforcement learning makes the model better into acquiring skills that we want to do. And in many ways, in both those cases, you get what you train for. If you want to do next token prediction, you can pre-train models very heavily and get really, really great models in next token prediction. If you want a specific set of skills, you train reinforcement learning models, and then you get them really, really great at whatever you are training for. Like there are basically no limits. Everyone knows these days that if you care about a skill, you just do reinforcement learning on that skill, and you get them all. That is excellent. It's kind of that simple and works. What people hesitate sometimes, where the moment of holdups are, how do those models generalize? How do those models perform outside of what they've been trained for? How do models do models do knowledge that is not in a pre-training corpus? Probably not. How do models do tasks that you don't reinforcement learning on? And probably not that great. These are basically the remaining questions in the world of AI, because what we train for, we are getting really, really good at.
And it feels like there's kind of two schools of thought here. One is, look, we're still early in this reinforcement learning paradigm. As we scale this up, we'll start to see, more signs of generalization. And so maybe these two scaling vectors alone take us to most of what we want from AI models. And then the second, being, really we need something new and different to kind of continue. Where do you kind of fall on that?
In some way, I almost think it's a question of the economics. It is pretty clear that if you like, scaling means in many ways adding data. That scaling doesn't work that much without data. So if you add more data that you want, then you get better models doing what you want. It's what you see right now every quarter, every lab releasing a better model. It mostly means they've both together with scaling more compute. More importantly, they added more data to the model, and most importantly, it was data targeted to what the previous model was bad. It's a really powerful methodology of training better and better models. And in that case, obviously iterating through it will give you a model that to do everything that you want if you keep adding the data to do the skills that you want the model to do. But this loop is slow in some aspects. And then the fundamental question can be faster. Because I believe it is very natural that with the paradigms of the methods of training models today, if we keep adding the data that we want the models to be good at, they will be good at it. And there is some amount of generalization within it. But the main question is there more? Is there some kind of research that would give us more results with less data in some ways, or more fundamentally better ways of models generalizing from what they've seen so far and what they've learned so far?
And I know we'll hit on some of those, future potential directions later. Maybe in the reinforcement learning world, just to kind of set the context for our listeners, how do you kind of characterize today, like what works and what doesn't? What's your own mental model? Is it literally anything we have data for? I know a lot of people talk about the difference between spaces that have kind of are easy to verify versus those that are a bit more difficult. What's your own mental model for what we can do reinforcement learning on today effectively?
The question about the easy and hard to verify often comes very close to what is easy to even get a signal on the quality of. Like if you'd like, and at some moment we've made a pretty good progress at OpenAI at training models that are meant to become great writers. And it is possible. Reinforcement learning can really be done on a lot of great things. Sometimes meaningfully, it is very hard thing to know what is good or what is not good, or you need to wait a lot of time. If you write a book, there are some easy ways to tell if it's a good book or not, but most likely getting a signal on that, you have to try to sell this book and see how many people will like to read it, how many people will want to buy it. And sometimes even that is not a good signal, because a lot of critics says, oh, this book is so good, just no one did buy it because marketing didn't work well. So how can we do reinforcement learning on writing good book? It's hard to say. How do people learn how to write good book? It is a very, very hard thing to say. Similarly with starting companies, there are lots of companies started early on, and how do we know which ones are good or not? Only 5 to 10 years down the line, we'll see that some entrepreneurs have succeeded and started really successful companies, and some of them failed. Was it because of some actions started early on were good or bad, or maybe it was a stroke of luck? Doing reinforcement learning on that very directly is a very, very hard thing to do. Everything where you get feedback of any kind, you can use that to do reinforcement learning on.
People have been blown away by the results that the models you worked on have gotten in coding competitions and math competitions and other things. And I think a lot of people are still trying to figure out their intuition for, do most tasks look like coding and math, or do most tasks look like books or starting companies or things that are actually very hard to build rewards and also just test tons of times? Maybe we'll take things like accounting or medicine or legal. Do you have a gut instinct on if those are more like the former or the latter?
I think fundamental question is how easy to tell if you did a good job or not, because arguably even for humans it's a very hard thing to tell if you did write a good book or not. With a lot of other work, if you can be, let's say, a manager of accountants and be able to tell which accountant is doing good job or not, if there are rules, then with those rules you can train whatever you want, really. For medicine, I've been thinking a lot about surgeons, and there clearly is a number of rules, and there are clearly sense of feedback of human have survived the operation, and that is a success criteria that is very good. But sometimes, and that is a very interesting way where really expert, really skilled humans go against the rules to do something differently that has ever been done before, and they succeed through that. If a surgeon really, through their experience, sees that they need to do this particular operation differently than all the others before, they go against the established practice, and through that they do something completely new that suddenly succeeds and makes the operation successful. I think the models would be able to do that too with some time and with enough ability to try. The question is how much time would it get today's models to really get to something like that?
As you think about the problems that need to be solved to kind of, make RL more and more generalizable for tasks that people care about, like, maybe help our listeners understand what are kind of the next frontiers for these other domains of RL?
Yeah, generalization, I think, fundamentally is a property of a model. So the story is whenever you train, you really affect your training objective, and that's kind of it. And a training objective, you can you get what you train for, and the question is how many other things you are getting for free. There are clearly methods of learning various bits, even next token prediction, that generalize poorly. There's nearest neighbor classification, very, very, very classical ML algorithm. You theoretically can use it for any ML problem there is. It just generalizes poorly because if it has very, very simple representation it builds of the world. Neural networks, how they work magically is that through large-scale training, for large-scale pre-training, they manage to learn very interesting, very useful representations of the world around it. And kind of it sometimes may seem like we get it for free. How has it happened that through training large transformer on the internet, it learns really to understand well a lot of the concepts around the world? Where does it come from? It's a magical part that comes from a transformer and a lot of parameters that we hammer over with gradient descent repeatedly. And this is the type of generalization we get from this model. There's a question: is there a different model that will generalize better? And it's almost surely there must be. The question is, how does it look like?
I've heard you talk before about, say that you kind of had updated your timelines maybe to be a bit longer for some of the, different aspects of AGI after working on scaling RL. Why was that?
I was definitely a very optimistic person in a sense of thinking we do reinforcement learning on our model and we'll get to AGI. And maybe we did. Maybe it already is AGI. Like the definition of AGI is a very personal. Exactly. It's a very personal thing. And in some ways it is everything we still don't have. So the models that can solve basically any Olympiad, any competitive problem, the models that are meaningfully right now solving new mathematical problems that no one has solved before. We get with the latest GPT 5.2 examples of that every week of someone achieving that. Is it an AGI? Like many people would say yes. At the same time, I'm a big fan of using coding models, and they still make mistakes. They in some places they do things I could take me really, really long time to do well. So they can be extreme force multiplier on doing programming work. But at the same time, there are clearly places where they fail. And I would say the biggest limitation of the models today is that if they fail, you get kind of hopeless pretty quickly. Sometimes you can do a bit of a back and forth between pasting an error message. Hey, dear model, this didn't work, try harder. Sometimes we need to do words of encouragement. But fundamentally, there isn't a very good mechanism for a model to update its beliefs and its internal knowledge based on failure, which this is probably the biggest update on me. Unless we get models that can work themselves through difficulties and get unstuck on solving a problem, I don't think I would call it AGI. Because of this feeling of hopelessness that if you hit a wall with existing model and they cannot solve it, they just cannot solve it. That they either try a different model or do it yourself. The intelligence always finds a way. Intelligence works at a problem and probes it until it solves it, which the current models do not really.
Well, I mean, it's kind of a great transition to some of the other research areas, maybe beyond kind of the pure scaling of pre-training in RL. And a lot of what you're talking about sounds, in a similar vein to continual learning, and a lot of topics that people have been discussing more and more, in public these days. I'm wondering, how do you maybe at the highest level for our listeners think about the set of problems that need to be solved, to make something like continual learning, actually possible?
Yeah, at a very core thing, being able to continuously train a model means being able to have the model not collapse and not go into the weird mode or like there are many ways in which training a deep learning model fails horribly. And a lot of the work that is happening in the big labs these days is about keeping those models so-called on the rails and keeping the training healthy. And it's fundamentally a fragile process. It is a process that you have to make effort to go well. And if you don't make that effort, it explodes. You just don't get a good model in the end. And that seems fundamentally different to how humans learn. I think human learning is much more anti-fragile in a way. It can get itself again. It is fundamentally robust. It can get itself unstuck. Throughout learning models with reinforcement learning, I've often really marveled at how infrequent it is for humans to crash out and then start talking gibberish and the brain to. And the human brain, after getting some new information, to spiral into some weird state, while the AI models do that. They do that pretty frequently, and it's something that researchers try to find both theoretical and practical solutions of how to fight it. And I think that this fundamental robustness of a training process is something that is necessary for continual learning.
How much of the ideas for, the maybe some of the interesting ideas for continual learning, how much of it does it feel like has been around maybe for a bit or has been discussed versus, is entirely net new research problem?
The main question is worth asking yourself, specifically as a researcher. That's something that I am asking a lot. Why hasn't it been solved yet? And that must be the number one. Like when someone starts working on problems like continual learning, which I think pretty clearly hasn't been solved yet, the main question is why not? What was the particular path that no one has taken so far, and why? There are many researchers in the world that are very smart, are having a lot of brilliant ideas, and so far no one has really cracked continual learning. And there are many hypotheses for it, but one fundamental one, I think, is that most likely it is a research that needs to happen at scale, at least at a certain scale. And there are only so many well-funded research labs in the world right now that can only do so much research and so many few research projects. That is most likely one of the really big reasons. If there is a research that you could do at a small scale and fundamentally discover something, it's probably there were a few, but either it would be something very complex or very theoretically difficult to do, or just requires already models and levels of compute that are available to very few. And it's very likely that the very few labs didn't go in a particular direction yet because they were busy doing other things.
I mean, I've heard you talk about before this idea that there's ideas in AI whose time isn't right, but they're still good ideas. And certainly we saw this with reinforcement learning and, it becoming much more effective after having large pre-trained models to be on top of. So it sounds like, your maybe intuition is that there are some really good ideas out there that maybe if actually applied at scale would be really helpful toward this domain of problems.
I definitely think so.
I've heard you talk before about the labs really converging on working on pretty similar stuff, right? And I don't know if that feels like that's been common over your past 2-3 years, but it seems like when you were leading a lot of the work in one that was a genuinely new thing that a lot of the labs were caught maybe flat-footed on. Talk a little bit about this convergence that's happened maybe over the last year, and was that surprising to you?
Yeah, even when training models with reinforcement learning, there is this well understood and well documented trade-off of exploration versus exploitation, and you wonder when is the right time to try different things than you've been doing so far, and when is the right time to try to optimize very, very well what you already know well how to do. And it's a trade-off that has no real solution because you don't know what is the unknown. Like whether exploration is successful or not fundamentally is is there any way that is different from the current one that would give me a lot? And unless you know the landscape of what you are doing, it's fundamentally a very hard thing to do. So it's like, I don't think there's a fundamental question about it. But I remember someone telling me at some moment in my life, why do all the planes, all the commercial planes look the same, even though there are a few companies building those? Because in the end, this is the most economically efficient design. In a way, what all the labs are doing today, the forces of economics are fundamentally very strong in that. And if you wanna compete, you need to have the best models offered at the lowest price. And the competition is pretty efficient there in terms of customers can switch whenever they want, and it's really the customers that are winning through that in many ways. But that is one thing that drives the labs to go for higher and higher efficiency and to go for produce better and better models in a pretty predictable way. And then there's a question of exploration versus exploitation. Should we try to sail over the sea and see what is out there? Should we try to train a model that is completely different? It would probably be it would probably walk away and lose some focus on trying to get the current thing better. You'll lose some focus in trying to get the current thing more efficient. But maybe there's something 10 times better. Maybe there's something 100 times better there. There's a question of a belief and conviction at the heart of it, of how much do we want to try those other things versus not.
And to your point, I mean, obviously there's such a clear path forward on adding more and more data, to RL in different domains, and that improving models for economically valuable tasks. There's kind of a clean roadmap to how each of the labs can, continue to, improve their underlying models. That it maybe makes it harder to go out and make that big bet. Whereas when it felt like maybe pre-training was slowing down, it's easier to go out and explore a bunch of different things.
Yeah, I think there are also just different times. In history, sometimes there's more appetite for it and a little bit of a freedom to explore various dimensions. The more competitive the landscape becomes, slightly it becomes harder, because it almost is something like a prisoner's dilemma.
Yeah.
Situation where we're trying to do things differently, exposes you very heavily to losing market share to other players.
Yeah. Do you think it actually, even matters for the labs if the next big breakthrough is discovered there? I mean, one thing I've been struck by is just the dissemination of a lot of these, advances. Obviously, O1, you were kind of the pioneer on the reasoning side. There's a few labs now that have great reasoning models, and I almost wonder if the labs would be just fine if the breakthrough happens somewhere else, because these ideas diffuse and eventually they'll be able to plug it into the existing business.
Ideas diffuse, and that's a good thing. But at the same time, the lead it gives you to be the first. I don't think it's something to really discount. In many ways, we have seen the fact that, if you believe that fundamentally there will be no place in the world for OpenAI to succeed, and it succeed because it went into pre-training transformer large scale much better than anyone else, and that lead made it one of the largest and most successful company in the history of the world. And in the same way, because of OpenAI being the first one to figure out how to do large scale reinforcement learning, I think for a long time, and still until today, I believe that it has the best reinforcement learning research program out of all labs, which allows it to do things better and more ambitious than most other labs that had to catch up to this much later. And while the ideas diffuse, the lead can be a very, very powerful thing that, if maintained, it will stay with you for maybe potentially forever. In many ways, I've been reading book about semiconductor manufacturing, which many of the core initial parts of the invention were done in the United States, and through that they slightly disseminated through the world through two various places. But at the same time, there has been moments and space of lead that a lot of other countries couldn't ever match the continued compounding of advantages over time for some of the countries that bet on it early and really started hard to build it. And it's not that there's only one country having successful semiconductor business, but it's also not every country. It doesn't exist everywhere. There always is a place whenever there is business shift. There are some newcomers that will be successful. There are some newcomers that will be unsuccessful, and some old companies that will stay and manage to turn themselves around, and some old companies that will die. That's the Darwinian part of progress.
No, and I feel like consumers and enterprises always remember the first company that introduces them to some, pretty magical experience. I mean, certainly you guys experienced those with ChatGPT. One thing that's fascinating about you is you obviously made all this incredible progress in RL, and we're help pioneering a bunch of this. And RL progress is still alive and well and going along, and we're making lots of progress across domains. And you decided to leave OpenAI, and I think you cited kind of different research areas you wanted to explore. I'm curious, like when did you kind of begin to know that might be something you wanted to do, and how did you ultimately make the decision?
It's definitely not something that happens very quickly. It's just something that slowly grows in a human, and OpenAI is not an easy place to leave, because I have many friends there, a lot of shared history, and a lot of I've built a lot of my life there, and for a long time really tried hard to make it work, and try to see what are the various places to do it. But at some moment, if you specifically as a researcher, if you wake up and if for any reason figure out you don't love your work anymore, you are not incredibly excited about what you are doing, then it's a good moment to try to explore and try to do something else. Like it is basically impossible as a researcher to do your best work if you are not 100% excited, and if you don't go with full enthusiasm. There were many days at OpenAI when I had basically infinite enthusiasm for the work I was doing, and was believing I was doing exactly the right things. But somewhere around at the end, it was getting harder and harder. So like that's kind of long story short.
Yeah. What are some of the things that are giving you energy today?
I think on a most fundamental level, what I did and what I've done, when I started OpenAI, I believed reinforcement learning is a necessary element of a path to AGI, and I really wanted to make it happen, and I really did, and like introducing reasoning to the reasoning models to the world has been to me a tectonic shift and a paradigm of how we train the models. And in some ways, I want to chase that high again and try to do something similar. Try to find something that is missing in how the world is training models so far, and try to make it mainstream as again in one way or another. But once you did something like that, it's hard to get another similar dopamine hits doing something else. So that's kind of what I would like to do, and I would like to have a bit of freedom thinking about how to explore it and try to attack the most core, the most important problems there are.
How much are you feeling like, hey, I've got dozens of hypotheses, or how much are you zooming out and being like, I've been so heads down in OpenAI, let me zoom out and kind of see what else has been going on?
In general, the real important hypotheses and the real important problems are most likely not something that will be new and that will appear to you if you worked on machine learning for 7 years. It's very likely what the important problems are. The main question is what I alluded to before, which means how do you solve it differently than everyone else? Because it means no one has solved it yet. So what is different, and what can be done differently than people in the past?
Well, I mean, I definitely want to hit on, OpenAI, and obviously you had such an incredible run there and time. One thing I've heard you say before was I think you've been at OpenAI since 2019, and you said every year felt like a different company in some ways. Yes. And so I'd love if you could just walk through that evolution and kind of, the how you kind of describe the narrative of the past 6-7 years there.
Starting with a small lab that is like 30-40 people, where we were always OpenAI from the very beginning was extremely ambitious. believing this is the place that will build AGI and that will create benefits of digital intelligence for the world. But starting from a few people trying to do a few kind of full projects that were incredibly ambitious to where it is today, which is again one of the largest companies in the world with a product that everyone knows and everyone uses, and it's almost hard to imagine not using it. It's been a wild ride, and as you also are aware, the execs at OpenAI have shifted throughout the years pretty significantly. So the type of people you work with every day has changed a little bit. The size of the company has changed. The themes of research have changed. At some moment, in the old days, there was no pre-training at all. Then for a while, it became kind of the pre-training company. Then for a while, I think it became pretty much largely our old company. And now it's a little bit more in a balanced way of a mix of those two, with many people living OpenAI and building both businesses and their life outside, and many new, fresh, great people coming in and doing incredible research inside. It's just a company that manages to reinvent itself and manages to grow through all the stages. Trying to imagine. I always had this weird hope, thinking of all those big successful companies, how incredible it would be to live through such a story of being there for those stages. And I feel like I've been through quite a bit of that at OpenAI, and it's an experience that I think is very hard to compare with something else.
I think everyone's eagerly awaiting for the definitive stories to be written about this chapter of OpenAI. When those stories do get written, I feel like people always like to focus on the kind of, the difficult, 51-49 decisions that could have gone either way that really like moved the company forward. Are there any kind of those pivotal ones that stick out to you?
Good question. I was only central to some of them. There were probably many that I didn't, that I like only was a background character. And probably even this discussion about releasing ChatGPT to the world or not, as you may have heard, and many people did, this popularity and its virality didn't, wasn't expected internally by at least no one I heard about it. I think in the end with ChatGPT and GPT-4 released soon thereafter, we created a bit of a moment and a bit of a momentum that was incredibly hard to predict, but made OpenAI largely what it is today. That was definitely a very, very, very important call on many axes and many decisions and many dimensions. Like the decision to pull a lot of resources to train GPT-4 at the moment it is, and with a lot of trade-offs that went there, again, remained very, very important and very critical in the history of OpenAI, and turned out to be a really good decision. And this, in the same way, betting and saying reasoning models are our future in a world where it was completely unsure of, and just a bit of first principles thinking and a bit of intuition that this is the right thing to do, allow the OpenAI to completely reinvent itself and say we are doing reasoning models right now, even though there is no product market fit, even though they seem to be kind of cool with puzzles. If you look at one, like it was a smart model, but it wasn't really good for anything practical, except for just trying around. Hey, we have a model that is kind of smart. Really, only with O3 and with a little bit of more investments into tool use with those models, we're able to start building something that started being incredibly useful for research, for coding. And from there, once you have the first signs of real product market fit, then humans are really, really good at optimizing something that exists and that they can see it works. But getting to that moment has been great journey and something to study, because it was not an easy thing, and OpenAI at that moment really passed the exam.
Yeah, no, I mean, I think what you describe is so interesting, of this idea of you have to keep scaling and investing in something, not quite knowing if it's really going to work or it's working. It's obviously very relevant to some of the things you're thinking about in the future too. With the reasoning models, like was it clear after O1 that this was going to be more than kind of fun and games? Or what was like the moment, the spark for you that you're like, oh, this is really going to work and we can really scale this?
I kind of believed in it from the very beginning, just because I believed in reinforcement learning. Again, my core belief from my very first days of OpenAI is that reinforcement learning is a necessary part of getting to AGI. And that was the main way was how rather than if. The question is, when are we ready to do it, and how exactly do we do it? And I fundamentally, but just since the day I started, I know this is what we need. And over time and over research, there came various experimental results that have informed us this is the right way of doing it.
One thing that's so interesting about OpenAI is obviously, I think Ben Thompson coined like this phrase, like the accidental consumer business. The idea that like obviously you were a research lab pursuing AGI and then kind of almost accidentally stumbled upon this incredible consumer product that was immediately picked up by the broader world. And I'm wondering, you talked about some of the kind of different chapters of being there. I think a question everyone always asks about OpenAI is the company's doing so many different things. They got the consumer product, core research, Sora, the enterprise product. Like, how does it actually work internally? And how do you kind of, do you feel that tension at all on the research side of getting pulled in a bunch of different directions?
One thing pretty clear is that OpenAI research operates very separately from the product and has from the very beginning, almost like you said, which is that OpenAI's goal and mission is to build intelligence. And that is, I think, the main goal and motivation of majority of research. There's like one team specifically built and directed towards product research. And that is the part of research that optimizes for whatever product metrics it is. And the rest of the research mainly focuses on how do we make our models more intelligent, and that tension really doesn't exist there. What I think is real and interesting is that OpenAI is at the center of probably the biggest technological shift of our lifetime, which means there is so much opportunity to do various things. It feels wasteful, and it feels imprudent to not try to do all those things, because basically everything in the world will be disrupted by AI. But it has a downside, which is very real and very, very problematic here, of focus. Companies are very bad at doing multiple hard things successfully. Companies are well known for succeeding at one very hard thing and then doing others similarly well to others. There are very, very few places in the world that can do a few of those things, and that is very, very hard thing to do. And I think this is a very, very, very big risk for OpenAI. Try to do everything and then not succeed at it. But like we will see if like OpenAI in a half focused state can execute well on all those side bets, or there will be other companies. Famously, and I think it's a little bit sad, OpenAI really lost focus on coding for quite a while when it focused on the consumer product, and that has costed a bunch of market share that it is working very hard on regaining right now. And I think OpenAI's coding models are really, really great these days. Again, but lost focus and lost lead definitely has a cost here. So there are like, in some way, like when you are a company doing AI in the world right now, you feel like a kid in a candy store, because there's so much potential of extremely valuable things that can be built for the world that it's hard to prevent yourself from doing all of it. But like, for everything there is competition, and there are questions who will do each one of those things in exactly the right way.
Yeah. Well, I mean, I think that's a great point to transition to just like the general ecosystem today. And you kind of alluded to coding, which I think has been a really fascinating space to watch play out. Why do you think Anthropic's been so successful at coding?
It's focus. I think focus can explain 95% of things. Why are companies succeeding in things? I know Anthropic's founders from even the time when they were at OpenAI, and they were always extremely fond on coding, and they always believed that it's a necessary and critical part of AGI, and I think I can only imagine how focused they have been on it over the years, and they definitely managed to get their vision very far with the latest model, with Cloud Code and coding agents. And I believe they are saying truth when they say very few people in Anthropic type code themselves these days.
And do you think that's kind of a foreshadowing almost of, pick the major labs that are out there, like each can kind of focus on different things, and so you end up with models that are particularly good at some things in different labs?
It's a good question, and I think there are multiple worlds in which we can be. There's a world where data matters. In that case, data is a very zero-sum game where you put the data into the skills that you want and your model is better at that skills. And in that case, we see splintering of the market into...
Because it's basically you can shift the data mix of what you're putting in, but ultimately it's at the cost of some other skill.
Exactly. And it's a little bit about shifting the data mix, but mostly shifting the work. Data is a labor intensive and slightly less money intensive, but it's largely very much labor intensive work in terms of research engineering. Let's call it that way. And so with that, just you have so many researchers that can work in parallel doing useful work on preparing the next data set. So if data drives the improvements, then we will see different labs being better at different things in natural specialization trade-offs. But if research is king, I think research has this magical property that is hard. It is high risk, high reward. But at the same time, if you have a good idea in research, it could improve your model in all domains at the same time, and you could leapfrog everyone in all domains naturally by just training better models. And which of the futures we are in, it's very hard to say right now, but we will see. We'll see if in the future which one.
Yeah, this current paradigm feels almost like very anti-bitter lesson, right? Where everyone's going off into specific domains and specializing and really putting in those. And you're right that it feels that there's this intuitive feeling almost that there must be something else that is a bit more generalizable.
I'm pretty sure there is. The question is how easy it is to find. So there is one version of the world which is not completely impossible, although slightly pessimistic on humans, that says coding agents are so good right now. Let's first get them to the moment where they can automate AI research, and then have the models like research better models, because maybe we are at the last model that humans could have figured out. And no, it's not a completely impossible framing. It's maybe it makes sense with all those GPUs we have and all those really capable models and their tenacity. Maybe they should be researching future models. But maybe there are still a few things humans can do that we can put our heads to work.
I feel like a lot of the top AI researchers, are working on coding for that very reason, right? This belief that it will speed things up. You've obviously worked on coding too. I mean, you spent time, a lot of time on Codex. How do you think about the next frontiers for these AI coding products? And it seems like we're on this just crazy exponential hill climb right now. How do you even conceptualize what these products will be able to do in a year?
Fundamentally, the whole story of coding is that we are able to program computers at a higher and higher level of abstraction in many ways, and we need to know less details and we need to track less details. And coding agents in some ways can be thought of as a higher level programming language that has very different semantics from all the other programming languages. And I think it's a trend that will. I think it's pretty unlikely that in the future we will be typing code ourselves. Very few people already do, and it's a one-way ticket. But at the same time, software is important. Software needs to be reliable, and there will be more and more progress in how do we get certainty about software doing the right things if we are not the ones typing it, and maybe not even the ones reading it. Fundamentally, I think those are all solvable problems, and I'm very excited about them.
It'll be interesting whether the core skill set to work with these agents, looks somewhat similar to a software engineer, or really everyone just becomes a PM, and it's really just about knowing, having some idea of what to go do, and the model's going for it.
Yeah, I think it's an interesting question, because I think almost the most important skill right now is being a skill of a good manager of junior software engineers. A lot of software engineers have been like a little bit reluctant of going to management.
Of course,
and really like to specialize in narrow domains. And I think like for a long time it was really the right thing to do. And understanding deeply systems is incredibly important. You need to combine deep understanding of computer systems with being able to give back at least a little bit of control, which what I think really the best managers are. The best managers understand extremely deeply the work of people on their team, but at the same time are able to give back some control for the people to drive their own destiny. And that's probably the best way how to work with models these days. You kind of everything that the models do, you understand the trade-offs and you understand what they are doing, but you allow the models to make their own choices and live with the consequences of them one way or another.
Around coding, one thing people are also trying to figure out is just where the various applications kind of fit in. And I think, there's, I guess, a few questions, like one being, hey, like you have the Codex, the Claude Code team sitting, right by the research teams. They build these great harnesses and products. Like, how do you think about the opportunity for companies like Cursor and Cognition, and to what extent is it like a disadvantage to not be, sitting next to the researchers at the labs?
It definitely is a disadvantage. I think the fact that the most successful AI companies of the world are training their own models is telling about something. And I kind of think, just like the future of big AI companies is to become a hyperscaler and run their own data centers instead of renting compute, the future of successful AI application companies to start training the models themselves. This is just how the stack works. But you got to start somewhere. So it may be the path that you start with the AI application that is successful, and then you first start post-training your own models, and then you start pre-training your own models if you are more and more successful, and then you start building your own data centers. Those could be just the natural paths and stages of success of being a good AI business.
So you think it makes sense for these companies to kind of do reinforcement learning on their own user data, post-train a bunch? And I mean, do they have any hope of catching? You have, endless compute going toward the big labs, endless collection of talent. Like if you focus on a very, specific domain, do you kind of have a hope of building a better model there? Or is it kind of almost a hopeless task in some ways?
Well, nothing ever is hopeless task. The future is not determined, but some of that is what I hinted before, which is the data important or is the research important? If the data is important, you can always try to differentiate yourself with the data, but it is not clear we are really in that world. Maybe there's a world where research is important, but that also allows the smaller companies to do some research that they think is better, and maybe win through research in the market.
But it seems like it almost requires a world where you have specific types of models that are focused on things being better, right, and not generalizing, right? So we get into a world of generalized models. It feels like it becomes hard for an application company focused on any specific task to have like the better pre-trained or large model.
Sometimes innovation comes from constraints. I think it is possible for a company focused on a specific domain, through seeing the deficiencies of the models on this domain, to create a model that is generally better. I don't think it is possible, and that could be like the next layer of success of this company. If you try to do really good model for X, and suddenly through that you make the best model for everything else, and then you grow, and then you become another big successful company.
I feel like in the past the problem's been you get better for like 1 second, and then the next generation of models come out, and you're like, oh man, we're way behind again.
Competition is difficult, and definitely we have seen for a while in the US tech landscape how big companies have tons of advantages, and this is true. But at the same time, there are new big successful companies coming up, so it's not hopeless. It's just hard.
Well, I want to, shift gears to the talent ecosystem and maybe, research itself, because obviously you've both are an incredible researcher and have worked with amazing researchers. Maybe to start, obviously researcher hiring is very competitive today. I know you were probably on the forefront of bringing folks into OpenAI. What determines what companies researchers join today?
It's a good question. In the end, people are very complex, definitely more complex than the models these days, which means everyone's incentives are different, what they want. And I honestly cannot really generalize. Whoever is hiring people should not think about how do I convince the most of the people to join me, and how do I become the most appealing place for researchers to do. It's probably a good question to be asking yourself. But I think there's a second one, which I think is much more important. What type of researchers would really want to work here, and then find those, because it's kind of impossible and very, very difficult to try to appeal to everyone. Just because of diverse preferences and diverse viewpoints and diverse ways of working. So it's much better to try to build a team that has some shared values, some shared approaches, because it's pretty clear that the teams that are aligned and that have the same goal move faster and work better than the teams that are not. So it's really should be kind of filtering on both sides and trying to just find the right people for the right group, and that makes everyone happy, that makes the group successful, and that makes the group more attractive over time.
Yeah. But there's been some interesting experiments around this, right? I think you had Meta famously offering, the first offer these mega packages. What's your kind of reaction to that?
Well, there are different strategies how to build a research group, and Meta at some moment, I think there are supply and demand curves, but they needed to make offers really attractive to start bringing people back after a few missteps in the world. And the momentum is a very hard thing to stop. If at any moment there is a perception in the industry that you are not doing very well, then you will not hire people, and then it can roll itself. So in many ways I think it was a really, really good strategy to try to change that dynamic and change the negative momentum in a place where AI is so important for every large scale business. And Meta has a very much new team built out that is training a new model these days, and a lot of people in the industry are watching. Will it be successful, and how it will be successful, and that will be determine the future of this lab. But it was definitely a good moment to bring in some new life into the Meta AI efforts.
I mean, you've obviously done a ton of groundbreaking AI research. You've worked with other great AI researchers. What makes a great AI researcher?
It's a good question, and it's a difficult one, because in many ways, being successful AI researcher, in many ways, it is about just being in the right place at the right time.
That's very humble of you.
but there is something to that. I think the fundamentals of being a great AI researcher these days, but in a span of my career, are one thing, being extremely good at both systems and engineering levels, understanding how computers work and how neural networks are trained, together with the theory of neural networks and optimization. It's very, very hard to be very successful doing only one of those things well. And suddenly, if you are at least okay in both of those things, it makes you easily 10 times more productive in any research endeavors. And I think this is an important part. The other one, it is if you want to be a successful researcher, you very necessarily need to have some ability to think independently, be able to get away from groupthink. People have kind of some natural tendency of converging on a median viewpoint of a group, which kind of kills research. I have this saying that if you have 100 researchers that think the same thing, you essentially have one researcher. Being a researcher means being slightly contrarian all the time because you want to work on something that is not working yet and that by default people don't really believe in. And that's being contrarian means like there's something that a lot of researchers that are extremely brilliant and extremely hardworking are like unfortunately missing is something, you can call it courage. In some way it is about standing up and saying, let's try to do something different. Let's do something in a way that most people don't believe in yet. And it's an extremely hard thing to do, especially in a world where experiments are so expensive as they are, and they involve so many things in a world of machine learning experiments being the cost of Hollywood movies. Directing one is like, it does require a lot, and you don't know. Like similar in the movies, you don't know if the movie will be successful, but with the big budget, you risk it buying stars and doing the best CGI you can. In the world of ML, you also try to de-risk and bring as many things as you can, stack as many advantages on your side. But in the end, experiments are experiments, and they are meant to go into the unknown, and either will be successful or not. But
yeah.
I think like if I were to say this is like knowing both systems and theory very well, it is about not following groupthink that much and then having the courage to state that to other people.
Well, we always like to end our interviews with a quick fire round where I stuff like all the other questions I couldn't fit in elsewhere into the end here and get your rapid reactions. And so maybe to start, what's one thing you've changed your mind on in AI in the last year?
Probably the last thing I meaningfully updated on is that I don't think a static model can ever be AGI. Like that continual learning is a necessary element of what we are pursuing.
Is that just because of something it won't be able to accomplish, or is it more that that it doesn't just meet the definition of AGI needs to have a continual learning aspect to it?
It's mostly about uncovering what our models are still missing. And then in many ways, you go layers and layers deep because our models are already good into so many things. But them being as brilliant as they are, it is clear that without it will never feel to me that intelligent. It will still be a tool that needs to be supervised by someone who has the ability to continuously learn.
Yeah. There's obviously a lot of AI progress happening in spaces we didn't talk about today. Like, what's your kind of timeline for a ChatGPT-like moment in the robotics space?
Probably around 2-3 years from now.
That's pretty bullish. I feel like everyone's still trying to figure out if there are scaling laws in robotics or if this stuff will actually, if there's enough data.
I think, honestly, between you and me, I think things are slightly better than most people realize. There are tons of companies making tons of progress, but always the progress needs some time to play out and some more investments to happen. But I think robotics will be doing pretty well over the next few years.
Yeah. And a similar sense on biology?
I think biology will take longer.
Why longer than robotics?
Just thinking from perspective of how much intelligence there is needed, how much precision to really manipulate biology successfully. It's a harder problem and require more fundamental investments to start to work.
Yeah, I guess most 3-4-year-olds figure out how to manipulate things in the world, but they're not world-class biologists. And so
something like that, yes.
What's one impact of this continued model improvement we're on that you think maybe we're underestimating or not talking about enough as a society?
It's hard to say, but fundamentally widely deployed work automation will be reality over the coming decades. And in one hand, we are talking about it, but on the other, I think we are not talking about it enough and seriously enough because the world will change. The world will change very drastically from where it is today. If there are some people who it is still not obvious today, it is obvious to me at least, and societal changes are slow, and I think it will be extremely weird. I think it will be probably painful in some ways, and we should try to figure out how to make it the least painful. But we need to think about how does the world look like where the job market is looking very, very differently than it is today.
I mean, I guess related to that, one thing I'm interested in, obviously been thinking about is, whether, you're kind of thinking about this has impacted the way at all you act as a parent, right? And how you think about, I guess, raising kids, and if AI has changed that at all.
The interesting thing, and I think I differ here to most parents, but I don't know. I'm not. My daughters are very, very young and very, 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 very small. So there isn't really that much. But I'm definitely not pushing them very, very hard to study these days. It's kind of hard to imagine how hard you can push 7-year-old to study. But I don't think I will be the parent saying, "Oh, you have to be the best in maths in your class." I don't think you will be like, "Oh, you have to win all those competitions." I don't think you have to be like you have to read all those books, because being a specialist, like when they will be grown up, probably will look very different, and it doesn't make sense to really bet on trying to find for your place in a job market anymore in that way. There clearly the ability to think critically will be always important, because if you don't think for yourself, no one else will. Even AI will not fully advocate for you in the way you want. But given how many unknowns there are, at the moment just want them to have happy childhood and have a good time as much as they can, and I hope they will also have happy adulthood if we don't screw up this AI deployment thing.
Yeah, I guess that everyone likes to talk about the existential risk side. Has your worries about that gone up or down these past years?
I fundamentally think and hope that no human wants the humanity to go extinct, which is a pretty good, the incentives are aligned for everyone in the world for the existential risk not materialize, which I really am not subscribing to that it is that easy to just make a model that will paperclip all of us. I think there are enough humans in the loop throughout all the process that just because it is in no one's interest that we will manage to be successful enough, and the people controlling the biggest clusters in the world will be responsible enough, because it's also not a good business to kill everyone. So capitalism is also fully aligned here. I think it's much more dystopian and much more worrisome if we push entertainment so far that is more interesting in the real world, and the humans will want to live in VR and only play virtual games, which is not impossible. I think much more realistic than all of us going extinct, but probably similarly bad.
Yeah, now it's like Ready Player One and WALL-E and all these kind of depictions of that world before.
So that to me is much more worrying. But this one we can only solve ourselves, really, and this is not an AI problem. This is a human problem. And what should our preferences be? So that's kind of how I've been thinking about it.
Yeah, I love that. I guess anything you're comfortable sharing at this point about what's next for you?
It's still very early, but I am thinking about it.
Awesome. Well, Jerry, this has been a fascinating conversation.
It has been nice chatting with you, and thank you very much for inviting me here.
I'm Jacob Efron, and you've been listening to Unsupervised Learning, a show where we probe AI's sharpest minds on what's true in AI today, where the space is going, and what it means for businesses in the world. I love doing this podcast alongside my day job as the managing director at Redpoint, where I've led investments in companies like Legora, Abridge, and Physical Intelligence. If you enjoyed it too, and found today's episode valuable, please subscribe on YouTube or follow us on whatever platform you're listening on. It's the best way to support the show, which helps us to continue to grow and get access to the best possible guests. Thank you so much for your support and listening. We'll see you next episode.